Stat students, welcome to your 3.2 Part 2 notes. We're going to continue in our journey to understand these things called confidence intervals. Yesterday we learned how to use applets to approximate using the 2SD method. Today we're going to go a little bit further in what we do and move toward theoretical approaches. So stick with me, this won't take long, and let's do a couple problems. Alright, first of all, on the first slide you can see here all formulas and a calculator, hence you can reference those things. We will use this formula quite a lot. It's the same one we looked at from yesterday, so nothing new there. We will talk about how we find that critical value Z star today. Let's jump into it. So here we go on our first example problem. I'll let you guys do the reading, but the summary here is we have a survey of 2,032 people, and we want to conduct a confidence interval, a 95% confidence interval, for the proportion of American 8 to 18-year-olds who had a television in their bedrooms in 2004. All right, so let's start by finding our standard error. That's going to be the first job we have in front of us. Now, since this is a proportions problem, it's a pretty straightforward process to find standard error. It's always the same idea. We just simply take our p hat, which is 0.68, times 1 minus p hat, which would be 0.32, divided by the sample size of 2,032, and of course the square root of that entire thing. And I'm going to do this on the calculator over here on the side. So 0.68 times 0.32 divided by 2032. All right, so we have our standard error, 0.0103. Now, if we wanted to use the 2SD method, we could just double that number and move 2 standard deviations left, 2 standard deviations right, and we'd have our approximate 95% confidence interval. We're going to be a little more precise this time, though. What we are going to do is actually find what we call Z star. Okay, so Z star is the multiplier in our confidence interval formula. Here's where it comes from. If you go back to your calculators and go to the Dister menu, and we're going to use inverse norm. Now, we used this briefly in the last chapter. We're going to use a little more here. I've got some numbers from an old problem on there. We're going to get rid of those. But here's the idea. If we're doing a 95% confidence interval, do a quick sketch of the curve. We know we're going to have around 2.5% on either side that we basically ignore. So what I want to find is, I want to find the middle 95%, but more specifically, I need to find these 2 critical values that I've pointed to right there. Now, right in the center of our confidence interval is going to be our p hat, but the question is, how do we find 95%? Where do we find these values? Well, here's the way I would think about this. This mark over here to the left, all this region right over here, anything left of this mark, represents 2.5% of the area. And by the way, over here, there'd also be 2.5%. And so what I'm going to do with inverse norm is I'm actually going to punch in 0.025. And by the way, you could do it all the way to the right and do 0.975 instead. And I'm going to go back to default settings on mu and sigma. Just we're using standardized statistics. And if I punch it in, and again, many of yours don't have the left, center, right option. I'm just going to leave it at left, which is the default, and I'll hit paste. Okay, so inverse norm of 0.025, 0, 1 gives us negative 1.960. What that means is I need to move 1.96 standard deviations left or right of my statistic and I will have those critical values for my confidence interval. So here we go. To find the confidence interval, we would simply do 0.68 plus or minus, and then we'd have our z star, which is 1.96, and then our standard error, which we found to be 0.0103. Okay, now this part that I'm underlining right here in red, this is what we call our margin of error. Just an FYI on that, because that'll come into play later. Margin of error. Okay, that is the plus or minus part of it. That what follows that is the margin of error. And when I clean this up a little bit, I found my margin of error to be, let's see, around 0.0203. And that led me to a confidence interval of 0.66 to 0.70. Okay, and to finish this, we have a phrase that we write on all these. It would be, we are 95% confident having tech issues, sorry. There we go. That the proportion of 8 to 18-year-olds in 2004 with TVs in their bedrooms is between 0.66 and 0.70. Okay, so it's a little wordy, but just like we had with our significance tests, we always want to finish with the script. And for confidence intervals, the script looks like this. It's the percent of confidence, the context, and at some point you've got to include the interval, of course. All right. If we move ahead, I'm going to show you an alternate way we could have actually done this problem, just simply using the calculator. I know I always wait to show this after we've done it by hand. I want you to know both ways, and it's really important that you understand this formula. It's very simple, but I am going to, like I said, I am going to go ahead and show you the alternative, aka faster way, which is to go into your stat menu and scroll over to tests, and then you have to go down pretty far because it's not the z interval, that's the tempting one, but it's this one right here, option A, the one proportion z interval. And I'm going to press enter, then I'm going to enter my numbers from this specific problem. So for this problem, we had a sample size of 2,032, and it didn't give us, X represents like the number of successes essentially. It didn't give us that number, but I'm just going to punch it in as 2032 times 0.68 because I can figure it out. All right, so it says 1381.76. I'm going to go ahead and change that to 1382 just because I don't think 0.76 people really exist here. And here we go. There are numbers. It's that simple. It is a 95% confidence interval, so I'll leave it at 95%. And voila, it is done. And again, they got essentially the same interval, 0.66 to 0.70. And you notice that p hat of 0.68 would, of course, fall exactly in the middle of the interval. Okay, now we're going to move ahead. And on this next slide, we're looking at this same problem, but we're basically saying, what if we wanted to redo this study and find out what sample size we would need so that we can control the margin of error. And they say they want the margin of error to be within 3 percentage points, 0.03. So remember from the previous problem, we sort of underlined this, but the margin of error is the part of the confidence interval formula that looks like this. It's Z star times the standard error. I'm not going to write the formula for standard error in here. I think that'll do the trick. So in this case, we'll have 0.03 is equal to, well, since it's a 95% confidence interval that we're talking about here, we can just simply use that Z star value of 1.96 that we used on the previous problem. And then our standard error, this is the part that's a little different because we don't know that the percentage is 68% anymore. And so in order to guarantee that we have a margin of error within plus or minus 3 percentage points, we want to be as conservative as possible. So what I'm going to do is use 0.5 is my p hat or my pi value, if you prefer to think of it that way. And we don't know the sample size. That's what we're looking for. Okay, so again, we don't know what our p hat's going to be, so we're going to use 0.5 because that gives us the largest possible standard deviation for our situation. It's the most conservative approach. Okay, so I've already kind of done the math over to the side, so I'm just going to kind of show you what I did. First, we divide by 1.96, and I got 0.0153, and then we still have our, well, I'm going to go ahead and change that numerator, 0.25 over n. Now we need to square both sides. Now this number, when you square 0.0153, it gets pretty small, but it's something like 0.000234, and then we'd have 0.25 over n. And then from here, we would just simply multiply both sides by n, and then divide by 0.000234, and I've got it as 1067.11. I'll show you the math real quick on the side here on the calculator if you need a second to catch up. So 0.03 divided by 1.96. Then we square that number. And again, like I said, it's just showing you times 10 to the negative fourth. But then we'll do times n, and then we end up essentially dividing. So I'm going to do 0.25 divided by my answer, and there it is, 1067.11. So the question is, how many people would we need to sample? And so if we want to guarantee a percentage, a margin of error of plus or minus 3, we would need to sample at least, and this is where you have to think a little bit. You're not going to do 0.11 people, but if you do less than that, that slightly increases the margin of error. So we would need to sample at least 1,068 teens. Okay, and that is the end. And I hope that makes sense to you guys. Do your best. Have a fabulous day.